So this is Dr. Kavita Singh, Associate Professor in Department of Civil Engineering in Institute of Aeronautical Engineering. So today our topic will be for discussion, Introduction to Digital Data. So till now in the previous lectures, whatever we have discussed till now, we were just discussing about the data, type of the data, how we collect the data, how we receive the data, what type of data it is, like all the satellite data, all the photogrammetry data we have all discussed in the previous lectures, and how the spectral property works on it, how the sunlight when it falls on the ground, when it falls on the different objects, how it works, how it reflects, how it is recorded. Now, when we talk about digital data, why we are discussing digital data here? Because after collecting all the digital data, we have to work with that particular data. So we should know that which type of data it is, in which format, how we receive whatever format we are going to utilize. That format we should know, right? So that's why we are going to discuss about the introduction to digital data. So what is digital data? Before we discuss the digital data, we have this few contents which we are going to discuss today. So that is about, first of all, we'll discuss about digital data and digital image data formats, band sequential format, band interleaved by line, and band interleaved by pixel format. So this all we are going to discuss in the contents. Like first we have to start with the first topic, that is about digital data. So in the previous topics also, in the previous lectures also, if you remember, we have just discussed about the pixels. Pixels, digital numbers. So if you remember what is a pixel, so pixel is like, if suppose this is the digital image, so it will be always converted into small pixels, right? So small pixels it has. So each pixel is having some DN value. Okay. So what is that DN value called? That is called as digital number value. Okay. So this DN value is given to each one of the pixel. So all the data which is converted to analog, converted to digital form, from analog to digital form, it has a DN value. Okay, so each pixel is having a DN value. So digital data is, it's a information, or we can say it's a language of machine, or which can a machine can understand, right? Like normally if we draw a line, we draw a point, we draw a polygon on a paper, we can understand what is that. But if you put that same thing in the machine will not understand. The thing is, the data should be converted to machine. Machine is always trying to read the digital format. So that's why we have to convert the entire data into the digital format. So this digital data is received directly from the satellite, directly from the aerial photograph, or else later if you don't have this digital data, the data is converted through scanning, automated scanning, and it is converted to digital format so that it is easy for the machine to read, right? So digital data is the electronic representation. As I said, it's an electronic representation of information in a format or language that machines can read and understand. Machines can read and understand. So if you convert the entire information to a digital format, then it will be easy for the machines to read and understand. So in more technical terms, when you talk about digital data is a binary format of information that's converted into a machine readable digital format. Now, why we are talking about digital data? Because till now, whatever we have studied in the course, it is about the data, right? How we receive the data. Now, in the coming topics after this lecture, coming lectures, we will be working with this digital data. Like GIS part will start, we will be working with this digital data. So, before we work with the digital data, we have to understand how it is converted and what type of data it is. So it is a machine readable format. It is converted so that the machine can read the information always, right? Now digital remotely sensed image is a typically composed of picture elements. Picture elements is pixels. Always remember what is a pixel. So pixel is a cell, small single cell of a image. So this is the image when you talk about the image. So this is the image when it is having very closed pixels, when it is having more number of pixels, that means it is having clear image. If it is the image is like this, if the pixels are like this, then it is having clear image because it has lot of pixels. Now for example, this image if I take and it has only this many pixels, so if it has this many pixels, that means this image clarity won't be there, clarity not there. Okay, clarity not there. Here the image will be clear. Okay, so at the located intersection of each row and column in each bands of the images. So digital remotely sensed image is typically composed of picture elements located at the intersection of each row and column in each bands of the imagery. Associated with each pixels a number known as digital number or brightness value that depicts the average radiance of relatively small area within the scene. So as I was telling you about digital numbers, each pixel is known as DN numbers or digital numbers. It is having a default value given by the machine, or we can say given by the computer system itself. So directly the data, when it is converted to digital form or it is received from the remote sensing data or photogrammetry or a digital camera. So the data when it captures the image is directly converted into digital numbers. So each pixel will be having digital number by default. Okay, so that is called as digital image. A smaller number indicates low average radiance from the area, and the high number indicates the high radiant property of the area. Like I said, if we have less number of pixels or when it has a smaller number of average radians, so the data will be having less clarity, and if it is having more number of radians or more number of pixels, the data clarity will be more like this. If we convert this data like this, so lot of pixels we can find here. So the pixels, if it is more, that means the clarity of the image will be more. So indicator of the high radiant properties of the area, if it is high number, from the low average to the area high number is an indicator of the high radiant properties of the area. So the size of this area affects the reproduction of details within the scene. As pixel size is reduced, more scene detail is presented in the digital representation. That means pixel size is reduced. What does it mean? Pixel size is reduced means this is what we are talking about here. So this is the pixel size is bigger, here pixel size is small. So if you reduce more smaller, if you make it more smaller, like if you make it more finer, see the pixel size is reduced here compared to this image. So the image clarity or the scene presented in the digital representation will be more clear. So this is what more detail we can find if the image is having more number of pixels. If less number of pixels will be there, then the image will not be having clarity. It will be having less number of information in present over there. Now here is one example structure of digital image, and this is multispectral image. So what just now we were talking about digital numbers. So these are all digital numbers like 10, 15, 17, 20, 21, 15, 16, 18, 21, 23, 17, 18, 20. All numbers are digital number, right? Now in this, if you see, we have many places you can find 20. So 20 is here, 20 here, 20 is here, 20 is here. So this 20 means it represents some kind of image, some kind of information in the image. So wherever this 20 will be there, so this will be having same kind of information in the image. So like this, if you find out 24, 24 is here, 24 is here, 24 is here. Only two 24s we can find. That means, for example, 24 means, let us say there is a building. That pixel represents the 24 number as building. So if 24 is here and here, that means the building is here and here. Now, when you talk about 20, it may be water body, right? So water body may be here, and maybe here. So this is how the language of the digital data. By seeing the image, it is very simple to see, but it is having a background, it is having a lot of digital information with a digital number, right? Now this is one multispectral image. So when we convert the image or scan the image, it is converted into pixels with the band combinations of 1, 2, 3 and now digital image data formats. So what are the different formats our data is having? So image data acquired from remote sensing are stored in different types of formats. For example, band sequential format, band interleaved by line. This is also one format, band interleaved by pixel. So these are the different three formats how the digital image data is reduced or stored. So it should be noted, however, that each of these formats is usually preceded on the digital tape by header and a trailer information, which consists of ancillary data about the date, altitude, and the sensor altitude, sun angle, and so on. Now, such information is useful when geometrically or radiometrically correcting the data. So the data are normally recorded on 9-track CCTs tapes with data density on the tape of 800 to 1600 to 6220 bits per inch. So this is how it is recorded in the CCTs tapes with the this bits, 800 bits, 1600 bits, or 6250 bits per inch. So next thing what we see here is band sequential format. So what is band sequential format? So band sequential format requires that all data for a single band covering the entire scene be written as one file. For example, I will talk about, suppose for example there is a red band, blue band, green band, or IR band. So for example it has 4 band. So 4 separate band it is having, separately it is showing. Now in this format what happens, it is combined together into a single format, right? So here will be red, blue, green, okay, IR band. So this kind of storage format is called as band sequential format. Like all the single data is stored into a single file, written to a single file. Like band sequential format requires that data for a single band covering the entire scene to be written in a one file. Thus, if one wanted the area in the center of the scene in 4 bands, it would be necessary to read into this location 4 separate files to extract the desired information. So if you want to get a information from 4 separate bands, you have to just check out for the 4 separate bands. Later, once you combine these 4 separate bands to a single image, then directly we can just search in the single image to get the information. So the number of tapes may be dependent on the number of bands provided by the scene. Now, this is the example what I was telling you about. So we have here a red band, green band, blue band. Okay. So these are 3 different band combinations. Like if you see here, 3 single band. These are the 3 single bands: red band, green band, and blue band. So now these 3 are combined together to a single band. Okay. Now all the colors are mixed together and it is converted to a single band, red, green, blue composite, we can say. So that whenever you want to find out any information, you can just search to a single image only. You need not go to the different layers of band. Like different layers are combined together to get a composite image. So this kind of data is called as band sequential format. Okay. So all the different bands are combined together to get a single band combination with all the bands together. Now let us see band interleaved by line format. So this is one more format how the data is saved. So in this format, the data for the bands are written line by line onto the same tape. So line by line it is written to the same tape. For example, that is line 1, band 1, line 1, band 2, line 1, band 3, line 1, band 4. Like that only if it is line 2, band 1, line 2, band 2, line 2, band 3, line 2 band 4 etc. Like that it is written for line 3. Line 3 band 1, line 2, sorry, line 3 band 2, line 3 band 3, line 3 band 4. Okay, so it is a useful format if all the bands are to be used in an analysis. If some bands are not of interest, the format is insufficient since it is necessary to read the serially passed all the unwanted data. Okay, so this is how it looks like. Just now we were discussing band 1. So this is row 1. So band, we can say here line 1, band 1. So this is line 1. Row 1 means it's a line 1, line 1, band 1, line 1, band 2, line 1, band 3. Now line 2, band 1, line 2, band 2, line 2, band 3. Right? So here some gap is there. So here row number 3. So line number 3, band 1, line 3, band 2, line 3, band 3. So this is how the band interleaved by line format. This is how it is represented. The data is stored in this format. Okay. Now we have band interleaved by pixel format. So I hope you remember what is a pixel. Pixel is a, what is a pixel? It's a cell. Okay. So as many cells we see with the DN numbers. So in this format, the data for the pixel in all the bands are written together. So taking the example of Landsat MSS, MSS is multispectral band, 4 bands of image data. Every element in the matrix has 4 pixel values. So one from each spectral band placed one after the other. So that is pixel 1 of 1 of band 1. So pixel 1 of band 2, pixel 1 of band 3. So like this we have pixel 1 of band 4 and pixel 1 or 2 of band 1. So it's a different combination interleaved by the pixel format it is represented. Again, this practical data format if all bands are to be used, otherwise it will be inefficient. So this format is not much popular but was used extensively by EOS Data Center for Landsat seen at the initial stage. So this is how it looks like pixel 1 of band 1. So here band 1 we have, so pixel 1 of band 1, pixel 1 of band 2, 1 of band 3. So like that pixel 1 or 2 of band 1, 1 or 2 of band 2, 1 or 2 of band 3. So this is how in a row the band interleaved by the pixel format it is represented. So these are the different formats how the data is represented. So band 1, pixel 1 of 2 of band 2 and so on. Again, this is a practical data format if all bands are to be used, otherwise it would be inefficient. So these formats are not popular but extensively by EOS Data Center for Landsat seen in the initial stage. So I think we have just covered about the different types of digital image data formats which are saved in the data formats, right? Now we'll just go through the references. So we have some few references which we have discussed in the previous lectures also, like this M&G Reddy Remote Sensing in JSBS publication New Delhi book. You can just refer for the pixel format or digital data format, or you can go through these links for the further for this digital data format so that you can understand more information. You can get more information about this data. So this is about the digital data, and this digital data we are going to use in the further GIS operations which we are going to discuss in the coming lecture. So this is how the data formats are saved in different tapes or different bits, so that always remember that the digital data is saved in a pixel format with a DN number. Okay, so this is how if the DN number, if the data is not converted to digital data, then we cannot work with GIS. To work with GIS, we have to convert the analog information, or we have to receive our digital data information to work with GIS data, right? So that's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.